I'm Amanda Staggy, and for Mrs. King's final AP Calc BC project, I'm going to be teaching how to do the integrating factors method. The integrating factors method is used when a differential equation is not separable. The model equation that integrating factors method uses is y prime plus pxy equals qx. And every time you want to use this method, your equation must reflect this model equation before you can begin. For example, the equation shown does model the equation for the integrating factors method, where the dy dx represents the y prime, the 3y represents the pxy, and the e to the negative 2x represents the qx. Therefore, since it is in the model equation form, we can begin using the integrating factors method. In the next equation, x squared plus 1 times dy over dx plus x times y equals 0, we can see that it does not reflect the model equation form. Therefore, we must transform it so it does reflect the model equation form, and therefore we can use the integrating factors method. Okay, so after dividing the entire equation by x squared plus 1, we get dy over dx plus x over x squared plus 1 times y equals 0. And we can now see that it is in the model equation form, where dy over dx represents the y prime, x over x squared plus 1 times y represents px times y, and 0 represents qx. So now we are ready to use the integrating factors method. Okay, so first off, I'm going to derive the integrating factors method. That way you'll understand better where the equations come from. Okay, so when deriving the equation, we first start off with d of mu times y over dx equals mu times y prime plus y times mu prime. Based on a later discussion, I know that mu prime equals mu times p of x. Therefore, I'm going to substitute mu times p of x for mu prime in the equation and rewrite it as y times mu times p of x. Next, we must factor out a mu, and after doing that, we get mu times y prime plus p of x times y. Okay, so based on the model equation shown earlier, we know that y prime plus p of x times y equals q of x. So therefore, we're going to substitute q of x for y prime plus p of x times y. So after taking the integral of both sides, we get the integral of d of mu times y over dx equals the integral mu times q of x dx. After taking the integral of the left side, we get mu times y over mu equals the integral of the right side, mu times qx dx. Next, we divide both sides by mu, and after doing that, we get y equals 1 over mu times the integral of mu times q of x dx. And finally, we see that y equals 1 over mu times the integral of mu times qx dx is the final equation for using the integrating factors method. The next step is figuring out how to find mu. When solving for mu, we can see that mu equals e to the integral of p of x dx. Next, we take the derivative of mu, and we get mu prime equals e to the integral of p of x dx times p of x. And since we already found out that mu equals e to the integral of p of x dx, we can substitute mu, so then we get that mu prime equals mu times p of x, which we used when deriving the equation above. Okay, so now let's do an example. We're going to use the integrating factors method to solve dy over dx plus 3y equals e to the negative 2x. Step number 1. Is the equation in the right order? So for this example, we can see that it is following the model equation form. Because the dy over dx represents the y prime, the 3y represents the px times y, and the e to the negative 2x represents the q of x. On to step number 2. We must determine which parts of our equation represent the variables in the model equation. So here's the model equation shown again, and we must figure out what variable in our equation matches the p of x and the q of x in the model equation. So obviously the 3 equals p of x, and e to the negative 2x equals q of x. Step number 3. We must figure out what the mu equals for this equation. Since we know that mu equals e to the integral of p of x dx, and we know that p of x equals 3, we can substitute 3 for the p of x in the equation, so we get mu equals e to the integral of 3 dx. And e to the integral of 3 dx equals e to the 3x. Now that we have what all our variables equal, we can move on to step number 4. Now we must use the equation we derived earlier, that is y equals 1 over mu times the integral of mu times q of x dx, and plug in our variables to solve. After plugging in what we know for mu and q of x, we get y equals 1 over e to the 3x times the integral of e to the 3x times e to the negative 2x dx. After calculating the integral of e to the 3x times e to the negative 2x dx, we get e to the x plus c, and we're going to multiply that by 1 over e to the 3x. After multiplying 1 over e to the 3x by e to the x and to c, we then get y equals 1 over e to the 2x plus c over e to the 3x. And our final answer is y equals 1 over e to the 2x plus c over e to the 3x.